Alright, let's do a little video on the law of sines. So first of all, this is the law of sines. Of course, it uses sine. And it says that these ratios are all equal to each other. So if you take the sine of an angle divided by the length of its corresponding side, that would be equal to the sine of another angle in its corresponding side. And all three of these are equal. Therefore, all three of them, when you look at the reciprocals, are equal. And so you can use it in either form, whether sine's on the top or bottom, as long as you stay consistent. And because they're equal, you can set these up with any two pairs that you wish. So that's all the law of sines is. Now let's see why this actually works real quick using an example. So if I were to draw a triangle, there it is. And let's label this angle, whoops, not that. We want the pen, there we go. Let's label this angle A, let's label this angle B. Therefore, the side opposite would be little a, little b. Okay? Now, I could come in here and I could draw in perpendicular height, h. Now, doing that, I could look at the triangle on the left, and then I could look at the right triangle on the right. So in doing that, on the triangle on the left, this would be opposite. That would be the hypotenuse. So therefore, the sine of angle A is equal to the opposite over the hypotenuse. Now in this case, h is the height, not the hypotenuse here. And on the yellow triangle, sine of b, because again this is also a right triangle, it would be opposite over hypotenuse. Now we could solve both of these for h, so this would be b times the sine of a equals h, and a times the sine of b equals h. Well, if both of these are equal to h, then that means they're equal to each other. So b sine a equals a sine b. Divide the left hand, both sides by b, divide both sides by a, and you end up with sine of a equals sine of b over a. And just to make sure that's clear, well, if I divided by ab and divided by ab, these a's would cancel, these b's would cancel. So I get below. And there was nothing special about this. All the labels were kind of arbitrary, and you can set up any triangle to basically do this, and then you get this equality to pop out for every pair of angles and corresponding sides. So there's a little quick proof of why the law of sines works. Let's put it into practice here. And so here's an example triangle of it. And you need to look, and what do I have? I have two angles, I have some sides. So I always think of it like this. I have an angle and its corresponding side. I have another angle and I'm looking for its corresponding side. So whenever you have angles and corresponding sides in this manner, that's law of sines. So, and what am I trying to solve for? I'm trying to solve for C, this side. So I'm going to use the version of the formula where the side is on top. And then I'd have little b over sine of b. And since I'm trying to solve for that, having that on top saves me some steps. So now let's just put everything in. C over the sine of 105 equals 7 over the sine of 35. Now remember, sine of 105 is just a number, so technically I could just multiply by those, and therefore I get C equals 7 times the sine of 105 divided by sine of 35. And that would be an exact answer. Of course, you could work that out and get an estimated value and take it a step further. But that's basically it. So look for those sides and their corresponding angles, and then set it up and solve.